Hello, participants. Welcome to this another session. As you remember, on the last session, we are considering this case that was the Ventura sales reporting. Let me brief this case again. This case is related to a company that is Ventura, which is having 1150 sales executives or 1150 sales outlets, and it has information from 60 sales executive or outlets only. So we have data from 60, but it has been mentioned that data is collected. So we have to prepare a comprehensive sales report and to draw inferences related to various aspects of the data. Yes, on the last turn we have discussed all these variables. Now we will proceed forward. We will proceed after that. As you know, since a report also requires a number of perceptions that are to be tested. But here the issues is we don't have data from all the outlets or from all the sales executives. We have data only from 60 outlets, means we have data from a sample. So there are a number of questions that may come in the mind of the decision maker. So let us consider some of the questions, then we will proceed forward. So I am sharing my whiteboard. Uh, so, uh, so to have some perceptions or some claims or some issues that are to be examined. Suppose the first question that comes in the mind of the decision maker is, the first question is, um, decision makers are considering sales for quarter one of the last year, and we have data from 60 outlets only, right? But the decision makers wants to have something on the entire 1150 outlets, right? So the first thing that they are considering, they have a perception, or they are claiming, they are having perception, or they are claiming that average sales of the outlets in the first quarter is 75,000, right? But we have data from sample only. So this is the first perception they want to check. Suppose now the second perception, as you have read that in the case that these outlets are situated in rural area as well as in the urban area. So they want to check whether uh, both type of outlets are having equal sales or not, right? Just to remind you again, they want to check this perception for the entire population, but the data is from 60 sample only. The third thing is, as you have read in the case, that there is an advertisement that has been imposed after quarter one. So they want to check the impact of advertisement. What do we mean by impact of advertisement? They want to examine whether sales have been increased because of that advertisement campaign or not, right? Means in short, since they are considering the short-term effect, so they want to compare sales of quarter one and quarter two. Obviously, if there is an increase in the sale in the quarter two as compared to quarter one, then it can be assumed, it is not certain, but it can be assumed that advertisement are having some positive impact. Just to remind you again that they want to check this perception, this claim about the entire set of 1150 outlets, but they have a SAM data from the sample. The fourth question, fourth issue or the fourth perception or claim is they want to examine whether the four regions, what are these four regions? They are northern, eastern, western. That the four regions, northern, eastern, western, and southern, are giving equal sales or not, are giving equal sales or not. Right? So obviously, as we know, these are the perception. These perceptions are made on the entire totality. So in this case, the totality is related to 1150 outlets. And these perceptions are to be checked on the entire set of the outlet. But we have data from a part of this totality. It means we have data from the sample. So they can examine, they can analyze only this data, but it is to be checked for the entire population. So these are the some questions, some issues that we are going to discuss. So here, what we want to do, we have data from the sample and we want to make inference about the entire population. So this concept is known as statistical inference. This concept is known as statistical inference. So today we will cover this concept of statistical inference. So let me share my PPT. So we will move forward. So this concept that we are going to discuss is also known as significance testing. Why this is known as significance testing? Significance testing is a part of statistical inference where we want to examine whether there is a significant difference, in between sample values and the population values, because the perception or the claim is related to the population and we have data from the sample only, right? So this word is significance testing. Means in short, we want to test whether there is a significant difference in between these two. So significance testing is a part of statistical inference that we are going to do. Just to remind you again, this is my email ID and the phone number. If you have any issues or anything you want to discuss, you can kindly contact me. So first we will introduce the conceptualization, where I am introducing some basic concepts that are very important for the decision making. The first one is the totality related to the problem situation, that is known as population. So here in this case, we have population of 1150 outlet. And sample is a representative subset of the population. What do we mean by representative? It is expected to exhibit the properties of population. And here we have a sample of 60 outlets. It is the convention that when we consider the population term, then either we use capital letters or we use Greek alphabets like alpha, beta, and so on. And when we consider the sample elements, we use small case letters or the Roman letters like the English letters. So this is the case. So this is a very common problem in all our researches. Whenever we write a research paper or we go for some PhD or the thesis, we want to examine about the entire population or entire situation. We want to make inference, we want to make some perception, we want to make some prediction about the entire population. Right? We since it is the thing, but actually the data is related to sample only. We collect data only from the part of the population because it is not practically possible or feasible because of an n number of reasons that we collect information from the entire population. So we will have data from sample only. Fine. And we have to examine this data, which is from the sample. Obviously, related to the sample, we are certain these are the things. But related to the problems, problem of the population, we want to check whether there is a significant difference or not. So today we are going to discuss this thing. So if we perform the population study, means each and every unit is being considered, that is known as census or complete enumeration. But if we consider only the sample data, that is known as sample survey. So in most of the situation, or in approximately all of the situation, we have data from the sample only. Obviously, if we are able to collect data from the population, then statistical inference or significant testing is not at all required. But this is not the case. So as I have mentioned, that statistical inference is inferring about the population on the basis of sample data. Actually, statistical inference consists of two parts. The first is estimation. Estimation means estimating the unknown population thing or the population parameter on the basis of sample. For example, we have taken a sample of size 60, and from this we get an average sale of suppose 71,000. So we can assume that the average sale of the entire lot of 1150 outlet in the first quarter would be 71. So what we are doing here, we are using sample values and commenting upon the entire population. So this is known as estimation. It is just like the case that we check, suppose we have gone to some grocery market and we want to purchase rice. We pick just a handful of the rice, check the quality and decide about the whole site. This is known as estimation. But we are in today's lecture, we are more concentrated upon significance testing, where we examine the declaration, perception, claim, assertions, or conjecture about the population, which is better known as hypothesis. As in the start, I have mentioned around 4 claims or assertions or perceptions or conjecture about the population, about the entire plot. So they are better known as hypotheses. Right? They are not the assumptions, they are the hypotheses. Hypotheses are the positive declaration about the population. So we want to check whether this declaration or this claim is correct or not on the basis of sample data. Right? We examine whether there is a significant difference or not. And it is performed through testing of hypothesis. We perform whether this hypothesis is to be retained or is to be rejected. So this is the concept that we have discussed. Now here we made 2 types of hypotheses. The number 1 is the null hypothesis. This is the hypothesis which is tested. Why the name null? Null means 0, means it assumes 0, means it assumes no difference or no relationship. And it is to be nullified through the testing. And the opposite to the null hypothesis is the alternative hypothesis. We are using binary symbols 0 and 1. Okay, so these are the 2 hypotheses that we are going to use in our testing of hypothesis or significance testing. Right? So let us have a hypothesis related to these 4 problems that we want to examine. Right? So here the first thing that we want to examine is we want to check the claim whether the average sale is 75,000 or not. So here we have 2 hypotheses. One is H0, other is H1. Right? So here the question is whether we are having an average sale of 75,000. Suppose there is an alternative claim that average sale is not exactly 75,000. It is less than 75,000, right? So we have two hypotheses. The first hypothesis H naught would be, since it H naught assumes no difference, so we can have H naught can be greater, H naught can be equals to 75,000. And H1 would be the alternative or the opposite of H naught. It would be mu is less than 75,000. So why we have H naught as mu is equal to 75,000? Because the rule for the null hypothesis is it assumes no difference. Means it is to be nullified. And it can also be written as mu is less than or equals to 75,000. Right? So there must be an equals to sign, whether the separate equals to sign or along with less or greater than in the hypothesis. Since this claim is on the average, so we are having hypothesis related to me. And this H1 is opposite to 75,000. This is the first hypothesis that we have discussed. Now, the second hypothesis is we want to examine whether these two type of outlets, rural and urban, are having equal sales or not. So here, actually, we are not examining a value. Here, we are examining a value. We are examining a value. But here, we are not examining. We are comparing a value. And what are these values? We are comparing rural and urban, and with respect to the average sale. So we can have null hypothesis as average sale mu of rural area equals to mu of urban area, right? Why we use equals to? Because in H naught, it assumes no difference, and we want to examine whether they are having equal sales or not. So this is the null hypothesis. What will be the alternative hypothesis? Since there is no such direction, we simply want to examine whether they are having average sales equals average sale or not. So H1 can be mu R is not equals to mu Q, right? So as you observe, we are using Greek alphabets. We are having Greek alphabet mu. And why we are using mu? Because this hypothesis is made only on the population or the population parameters, right? So that's why we are using capital case letters, or we are using Greek alphabet. This is the convention. So this is the hypothesis for the second set. Now in the next case, we want to check whether the advertisement is effective or not. Means we want to compare the sales of Q1 and Q2. What H1 says? That H1 says that there should not be a significant difference. So H naught can be mu of quarter 2 is equal to mu of quarter 2 is equal to mu of quarter 1. Means average sale of quarter 2 is equal to average sale of quarter 1. Right? And what would be H1? If we write this hypothesis, means there is no significant difference. Since there is no significant difference, so we can say, if all other factors remaining the same, that advertisement is not a success because it is not resulting in the sales increase. And H1 would be opposite to H0. So what would be the H1? Mu2 is greater than mu1. Means there is a significant increase in the sale. So we can say that advertisement is a success. Okay, this H0 can also be written as mu2 is less than or equals to. Why? Even if the sales has been decreased, then also we can say that advertisement is not a success. But there should be equals to sign in H0. Fine. And in the last case, when we are comparing the sales of the 4 outlets, so H0 demands that there should not be any significant difference. Means average sale of the northern regions equals to average sale of the eastern region equals to average sale of the western region equals to average sale of the southern region. Means all these sales are equal, right? So it means all sales are equal. and H1 is opposite to H0. So since H0 is that there is no significant difference, all values are same. So it is not necessary that all are different also. Means even if a single mu is different from all others, then also we can say that H0 doesn't hold. So H1 can be written as at least, means one or more than one. At least one mu I is different from others. Okay, so these are the examples of some of the hypotheses. So let us move back to, uh, to the slides. So here we have discussed. Uh, Actually, it consists of the 5-step testing process that we will demonstrate through the example. So first we set up the hypothesis. Obviously, this setting up the hypothesis comes from defining the problem. Means we are considering the problem situation. Accordingly, we develop the population parameters and the hypothesis. It comes from the defining of the problem, means what problems are important to you. As you observe in H0, there must be an equals to sign, either that is separate equals to or along with less than or greater than. And in H1, there won't be any equals to sign because H1 is opposite to H0. So this is the first step that we are setting up the hypothesis. Now, since we have making this hypothesis about the population, and we have data, and we are going to have data from the sample only. So we make a statistical rule or process to decide whether to reject or fails to reject the null hypothesis. Right? You must have observed that we haven't used the word proved or disproved. So why we haven't used the word proved or disproved? Because proving and disproving is a big thing, and it can be possible only if we have data from the entire population. But we are not having data from the entire population. We are having data from the sample only. So at most we can reject, and if we don't have substantial reasons of substantial evidence to reject, then we have to means we fails to reject, means we have to accept or we have to retain the hypothesis. So this is the rule that we decide. So how it is done? It can be done. It can be done by dividing the sample space of the sample statistic. What do we mean by sample statistic? So let us have an example and we will discuss this again. So I am taking up the first first case. Here the H0 is, we are having average mu is equal to H75, and H1 is sales is not that much. So mu is less than 75. So if this is the case, then we can say that the claim of 75 holds. And if this is the case, then we can say claim of 75,000 doesn't hold. Sales are below 75,000. So this is uh, the hypothesis that we want to do. Right. Now the first thing, having a sale. So what we have, the first assumption that this sale is following normal distribution. As we mentioned, normal distribution, we have to mention mu and sigma. Mu is the mean of the sale and sigma is the standard deviation of the sale. Suppose this assumption holds. Right? Okay. Since this mu can be exactly known from the population, and we are going to have a sample only. Suppose the size of the sample is n. So from sample, we can calculate sample mean. That is x bar. Right? This x bar, since this x bar is calculated from the sample. So in general, this is known as sample statistic, right? Because anything that is calculated from the sample that can be used for the estimation of the population or population parameter is better known as sample statistic. This sample statistic is a random variable. Why this is a random variable? As we know, this is not, we have a population of size 1150, and from here we have a sample of size 60 only. So we can have around capital NCN number of samples possible, means we have n number of samples possible. Since there are n number of samples possible, so this sample mean x bar can take different values depending upon the sample, and we are not going to consider each and every sample. So it can never be known with certainty what this value would be, means it will behave in a probabilistic manner. So this sample statistic is a random variable. Since this is a random variable, so there must be a distribution of this sample statistic. I'm just giving you the concept, right? So that the things would be very clear to you. Otherwise, when we run the SPSS, these concepts are embedded in that. So that won't face any, you won't face any problem, but it is very important to understand the concept. So this random variable is having a distribution. So this distribution of sample statistic is better known as sampling distribution. Right? So here we are having sampling distribution of sample mean or sample statistic x bar. Right? So it can be derived, in statistics we derive that if the parent population, I'm just giving an example, if the parent population is following normal distribution, right, with mean mu and standard deviation sigma, then sampling distribution of x bar will also follow a normal distribution with mean mu and standard deviation or standard error sigma upon root n. Right? Means it will follow a normal distribution. Right? So it is following normal distribution. This is the curve for the normal distribution. In the center, we are having this value, mu is equal to 75. Right? So this is the normal distribution. So what do we mean by it, performing the test? We divide this probability distribution of sample space into two mutually exclusive parts. One part gives rejection of H0, other gives retaining of H0. Right? Since rejection of H0 is possible, rejection of H0 means we are going to have H1, and H1 is giving a lower value. So here the rejection is possible only on the lower side, means when values are substantially low. Let us take an example. Suppose in some case, in the first case, X1 bar from a sample comes out to be 73, right? And in the second case, in some other sample, X bar comes out to be 33. So when you are having a value of 73, then you can say that 73 is not much different from 75, though there is a mathematical difference. But remember, these are the values from sample only. So you can say, okay, with change of the sample, these values might be different. And this is not much of the difference, means there are less chances that we are not having a population mean of 75, right? So you can say, since this value is very close to 75, so we are not going to reject the null hypothesis. But suppose, means you compare the difference between 75 and 73, and you can say that this difference appears to be small or insignificant. So there are chances that H naught won't be rejected. In the same manner, you will compare this 33 from 75. And here you observe that there is a large difference. Since there is a large difference, so you can say there is a significant difference. There is a big difference. Since there is a big difference, so there are chances that this value won't hold, means we would reject H naught. And in the first case, since the difference is not so okay. So you will speak in the language of chances only, that there is chances that we would reject. And here, when the difference is not that much, then you can say that we fails to reject H naught, or we will retain H naught. So accordingly, we divide this whole probability distribution into two parts. One part is known as acceptance region, where we don't reject H naught. So where we retain H naught, we do not reject H naught. This is the part. And here in this part where the difference is substantially large, then you can, this part is known as critical region, where you recommend that if values falls in this region, you will reject H naught. So what do we mean by test, making a test? We divide this sample space or this sampling distribution into two mutually exclusive parts. One is acceptance region, where we don't reject the null hypothesis, and other is the critical region, where we reject the null hypothesis. And this dividing point where the critical region starts, this dividing point is known as critical value. Right? So these are the concepts. Since here we are considering H1 with the sign less than equals to, so we are considering on the left side, if H1 will be greater than 75, then this critical region would be on the right side. So we have two types of tests, left tail and right tail, and they are in general known as one tail test, since only one tail is involved. But suppose in some other case, you are having the hypothesis as H naught as mu equals to 75, and H1 we are having mu naught equals to 75. So here on here we are considering the significant difference on both the sides, whether the values are significantly large as compared to 75, or values are significantly small as compared to 75. So we are considering the difference on either side. So here in this case, we have critical region on both the sides, right? So this is the critical region on the left side, as well as this is the critical region on the right side, where we reject the null hypothesis. And in the middle, we are having acceptance region. So this type of test where not equals to is there, this is better known as two-tail test. Right? So we have two type of test, one-tail test and two-tail test. Here again, we are having two type of uh, critical values on the left side and on the right side. Right? Okay, so let me share the PPT again and explain this concept. So here we define the test that I have explained. In the same manner, we have discussed the critical region as well as acceptance region, and we have two type of tests. And the other thing is, we can convert these values into the standardized scale, which is better known as the test statistic. So as we discussed, here the test statistics would be X bar minus mean of X bar, since the sample statistics X bar, and the mean of x bar or mean of the sampling distribution would be mu. It is divided by standard deviation or standard error of x bar. So it is given by sigma upon root n. So this is the test statistic. This test statistics would follow Z distribution or standard normal distribution. Okay, so here we are having the standardized scales of the test statistic. Right? So as we have discussed, since we are considering the sampling distribution of test statistic, so what we have assumed? We have assumed that sampling distribution is following normal distribution. So this type of test, which we are discussing in the starting or in the at the first step, are known as parametric tests. So where the assumption of normality is very much required. But in all the cases, normality assumptions cannot be made. So if we cannot make the normality assumption, they are known as non-parametric tests. Right? Now the issue arises how we decide the criteria, how we decide the critical values, how we decide the significance level. So the concept is we put significance value equals to size or probability of critical region, right? And here the values that is most common is 5%. This is not always the case, but it is the default value that we can have 5%, but values can be at 1%, it can be at 5% also. So if we take the value of 5%, the size of the critical region would be 5%. And accordingly, we develop the critical value as per the distribution that we are using. So this is known as Z critical. So this critical value is being determined depending upon the level of significance or alpha. We take, if alpha is 5%, then we have different critical values. If we take alpha as 1%, then we have some other critical values. So this is the third step. On the fourth step, we take sample, we collect data and observe and calculate or estimate the observed value of test statistics. Since x bar has been calculated from the sample, we have mu from the hypothesis, we have sigma and root n. So we collect the test statistic. Then we compare these two values, whether these values are, this observed values, right, whether the observed values is falling in the acceptance region or this observed value is following in the critical region. So if observed values are following in the critical region, we would reject H0. And if observed values are not following in the critical region, following in the acceptance region, then we won't reject H0. So this is the case. And there is a better method that we use in the software that is known as probability value. This is an alternative way of hypothesis testing. This probability value of p value is also known as right tail probabilities. Right tail probabilities of the statistic or the test statistic. And there is one more explanation. They gives us chances of, they gives us, since probability word is there, they gives us chances of having such a difference. Means having such a difference, such or more than a difference, right? So if this, let me have the whiteboard and explain this concept on this whiteboard again. So I'm explaining the concept of the p-value. So p-value is also gives the chances or the probability of having such an extreme value or equals to, extreme means equals to or more than, equals to or more than of the test statistic. Right? Let me consider two values. Suppose p value, sometimes in software it is expressed by significance also. Suppose this p value is 0.001, means the chances of having such a difference is just 0.1%. Right? 0.1%. Obviously, this is a low value. Means there are very little chances that the values would be so much different. Since it is a low value, so we would reject H0. Right? And suppose we take one more example. Suppose the value of Z is 0.342. 0.342 is 34.2%. So what we say, that chances of such a difference is 34%. Obviously, this 34% is not low. Right? It is not low or it is high. So the chances of having such a difference is not low. Chances of having such a difference is high. So we fails to reject H0. We fails to reject H0. Right? So there must be some dividing point, and we divide this point by alpha or level of significance. So if p value is less than alpha, suppose we are considering 5%, then this value is supposed or considered to be small, and so we reject H0. And if in the other case, if p value is greater than alpha, is greater than 0.05, then it is not considered to be small, not small. So we fails to reject or retain H0. Right? So this is the concept that we are discussing. Right? Here it has been mentioned, if p value is small, so we reject the null hypothesis at 5% level of significance if we are taking 5%. So now, just like in our first case where we are considering a particular value, means we have the hypothesis as mu equals to 75. So we require only one sample. So these type of tests are known as one sample. Here we have two type of tests. One is Z test. So this Z test or the standard normal test is there only when population SD sigma is known. Why this is known as Z test? Because our test statistics follow the Z distribution or the standard normal distribution. But in all real life situation, this population standard deviation is not known, because we are collecting data from a sample, or we are collecting data for the first time only. So in most of the cases, in approximately all of the cases, this population standard deviation sigma is not known. Since this sigma is not known, so it is estimated by sample SD, that is S. Right? So here sigma is being estimated by sample SD S, and it will follow some other distribution. Obviously, derivations are there. This distribution is known as student's t distribution with n-1 degrees of freedom. Means the degrees of freedom are the statistical information that are there. Right? Why we have n-1? Because 1 degree of freedom is sacrificed in estimating sigma. Sigma is being estimated by S. So 1 degree of freedom is being sacrificed in estimating it. So we have n-1 statistical information available with the sample. So this is known as T statistic. Now we will go to the spreadsheet and perform this test.